We left off talking about different types of concentration units. This one is mole fraction and mole percent. So mole fraction is, I believe that's chi, solute. It's a large, funny-looking X. It's a Greek letter. And for mole fraction, we're looking at the moles of the solute divided by the total number of moles in the solution. So that's going to be moles of solute and moles of solvent added together. So the fraction is the part over the whole, right? So the part is moles of solute and the whole thing is moles of all the things. And then we can also do a mole percent, which is the mole fraction multiplied by 100. Okay, so this one slide has a lot of converting units problems in it. So a solution is prepared by dissolving 50.4 grams of sucrose in 0.332 kilograms of water. The final volume of the solution is 355 milliliters. Calculate the concentration of the solution in each unit. So again, let's identify the numbers that we're given. We've got this many grams of sucrose. We've got that many kilograms of water. We've got a volume. And we want to calculate the concentration in these different units. So the first one is molarity. Well, to calculate these concentrations, we need to know essentially what the formula is. So molarity is moles of solute divided by liters of solution, right? So did they give us moles of solute? No, they gave us a mass of sucrose. But we can convert that. So we've got that many grams of C12H22O11. And we can convert that to moles using the molar mass. So we'll calculate that really quickly here. Whoops. 12 times 12.01 plus 22 times 1.008 plus 11 times 16. 342.3. Close enough. Okay, so 50.4 divided by 342.3, 0.14724 moles. I'm going to be using this in the calculation, so I don't want to round it off here. I want to keep my 2 extra digits. So that's the moles of sucrose, so that's what goes in the numerator here. 0.14724 moles. And then we want to divide by the volume of the solution in liters. We're given the volume in milliliters. So 355 milliliters. A fast way to convert to liters is, instead of writing the prefix milli, let's write what it means, which is times 10 to the minus 3. So I've got the 0.14724 divided by 355 EE minus 3. And I'm going to get 0.41476, which would round to 0.415 moles per liter. Any questions? Next, they ask for the mole fraction. So this is a lot like mole percent, which is a lot like mass percent, right? The mass of the solute divided by the mass of the whole solution. Here we want the moles of the solute divided by the moles of the whole solution. So we just calculated the moles of solute, but we need to find out how many moles of water there are in this solution. So we were given a mass of water in kilograms, 0.332 kilograms. So I can sub 10 to the 3 in there for the kilo, and that's grams of water. So I'm going to convert to moles using the molar mass of water. And I did that wrong. I used -3 instead of +3. I'm like, no way, that is seriously messed up. (18.424 moles of water. So mole fraction, this is going to be moles of sucrose. I'm going to call sucrose Su, divided by moles of sucrose plus moles of water. I need the total moles, everything in the solution. So I've got 0.14724 moles divided by the sum, 0.14724 plus 18.424 moles. You want to be careful when you do this on your calculator because it's easy to go wrong. Which I did. 1, 4. Okay, there we go. I'm getting 0.0079284. Anybody else get that? Yeah. Good. A fraction, a mole fraction, a mass fraction, anything like that, has to be between 0 and 1, right? Because if it was 1, it means it's just pure solute, right? It's just pure sugar. And of course, you can't have a negative mole fraction, because then you'd have a negative mass of something, which would be silly. Any questions about that one? There's no units because moles and moles cancel out. Yep. Molality. This is not a typo. Molality is different than molarity. So molality is moles of solute divided by kilograms of solution of solvent, which is the water here. Not the whole solution, the kilograms of the water. Well, we already have the numbers we need for this. 0.14724 moles divided by 0.332 kilograms. kilograms. So 0.14724 divided by 0.332, we get 0.44349, which is 0.443 molal. That's funny, lowercase m is the molality, which is the same as moles per kilogram. Notice how the molality and the molarity are pretty close to each other, right? Molality is used when we need to do away with the temperature dependence of molarity. Molality does not change with temperature. So mole percent, how do we get that? Yeah, we're going to do the mole fraction again and multiply by 100. So this will just be our 0.0079284 times 100 to make it a percentage. So this will be 0.793%. And then the last one here is percent by mass. So percent by mass, we're looking at the mass of the solute divided by the mass of the whole solution. So grams of SU divided by the whole solution, that's going to be grams of SU plus grams of water. And then multiplied by 100. And there will probably be a question like this on exam 4. And one of the things that, or the mistakes that students often make is they will use the mass of the solvent instead of the mass of the whole solution. And I will probably try to trick you with that on the exam question, right? So watch out for that. It has to be the total of the solute and the solvent masses. So we were given the mass of sucrose, 50.4 grams. And so down here I'm going to have that 50.4. And I'm going to take the kilograms of water and convert that into grams. And I don't feel like writing it in scientific notation, so it's 332 grams. Oops. I just took this and multiplied that out. So 50.4 divided by 50.4 plus 332 times 100, 13.179%. So we're going to call that 13.2% by mass. Any questions? So you should be able to do calculations like this. I do not expect you to memorize the formulas for all of these different concentration units. So those will be on the list of useful information. So you should look at that and make sure that you understand what all the variables and symbols mean.
Would you ever ask us for the percent by mass of the water?
I could ask you for the percent by mass of water in the solution. Yeah. And so if we have the percent by mass of the sucrose, then the difference between that and 100 is the mass percent of the water. Yeah. Any other questions? Here's another question. What is the molarity of a 10.5% by mass glucose solution? The density of the solution is 1.03 grams per milliliter. Just really hung up on sugars here. Not sure why, but. So that's the percent by mass of glucose, and here we have the density. And they're asking us to find the molarity. This one's a little bit tricky. So let's write down what we have. We have 10.5% by mass. So let's write that out as 10.5 grams of glucose per 100 grams of solution. And then we're given a density 1.03 grams per milliliter, and that's the density of the solution, so that's grams of solution per liter of solution. And then over here we want the molarity, which is moles per liter. Now, in a lot of problems where we have more than one number over here, one of them is going to be a number without per units, right? It'll just be a mass or a volume. And so then we're like, that's the one we're going to start with because we can't use it as a conversion factor. Here, all we have are per units, and we're trying to get to per units, right? There are different approaches to solving this problem. So I'm going to show you the one that I think is the best for most students. So most students would tell you that fractions are not their friends, right? So let's avoid fractions wherever possible. So what I'm going to do is I'm just going to draw a line here. And this is not a fraction anymore. This is just two separate calculations. I'm going to take 10.5 grams of glucose and convert that to moles of glucose. Well, that's doable, right? I can do that in one step. Molar mass. They gave us a formula. We can figure that out. And then I want to convert 100 grams of the solution into liters of solution. So this is moles of glucose per liter of solution. So I've got grams. I'm trying to get to liters. I'm going to need a step in the middle. What's that going to be? This would allow me to convert grams of solution to milliliters, right? So I can convert to milliliters of solution using the density. And then using our knowledge of metric prefixes, we can convert milliliters to liters. So 10.5 grams of glucose, that's C6H12O6. And I'm going to convert this to moles, dividing by grams, need the molar mass, 6 times 12.01 plus 12 times 1.008 plus 6 times 16, 180.2. So 10.5 divided by 180.2, 0.058269 moles of glucose. Oops. So I did this conversion and I ended up with this. Now I'm going to do the part on the bottom. I'm starting with 100 grams of solution. And if you're paying attention to sig figs, you might be concerned that that has 3 sig figs or 1 sig fig, or it's not clear. Because this is a percent, that 100 is exact. The measured part is the 10.5 per 100, so exactly 100. And I'm going to use the density to convert. So I'm going to have grams of solution down here and milliliters of solution up there, because I'm going from grams to milliliters. Oh, I didn't cancel those units. So grams of solution, cancel grams of solution. And then I'm going to convert to liters. Liters on the top and milliliters on the bottom. So our density, 1.03 goes with the gram, and so that goes on the bottom this time. Sometimes it's on the top, sometimes it's on the bottom. Here, millis in the denominator, but 1 milliliter is 1 times 10 to the minus 3 liters. So 100 divided by 1.03 times 1 negative 3. This is 0.09709 liters. Wait a minute. This was exact, but the density only has 3 sig figs. So this is the part from the bottom, and that's this one right here. So now I'm just going to take the moles of glucose. I'll sneak it, not like that. Let's use maybe a different color. Sneak it in here. 0.058269 moles divided by 0.097087 liters. So that's a molarity of 0.6.
If we wanted to keep it like, as a fraction, we would probably have the same answer, right? Or would it
Yeah.
be screwed up?
Yeah. You can convert this by putting all these factors together in one equation. But when you're converting this, then these units, this path has to be on the bottom, right? And so students sometimes get a little twisted up about that. So if you know how to do that, go ahead. It'll save you the step of dividing things at the end. But it's not that much faster, and it's not better if you get the answer wrong, right? So always better to do it slow, the way you understand. Any questions?